My name's Andrew Stokes, and my topic today is how to run a level test across 17 time zones. If we went back in time a couple of years, this would be a rather odd title for a talk. Why would you even want to do it? Placement tests used to happen after students arrived, and as often as not, they'd happen with pencil and paper. But things are different now for two reasons. Firstly, more normal courses are taking place remotely. By normal, I mean the courses that would have taken place on-site 2 years ago. And secondly, universities and language schools are reaching out to students in new countries or new parts of the world. For example, just the other day, I was talking to a university in Queensland, Australia, who are now teaching students in West Africa, Cameroon, I think it was. Many of these students would never have come to Australia to study, but they are able to take courses remotely. It's taken the pandemic to nudge us into a different world where we are better able to see the value of technology in the arena of testing. What this means is that we need to have a greater focus on making sure the remote testing procedure works effectively, both for the teachers and administrators in the institution, and of course for the students themselves. So for the next 15 to 20 minutes, I want to focus not on the contents of the test, but on the operations side. And I want to put this in context by telling you a story. The story is about how we had to run 2,000 tests over a 2-day period across, yes, 17 time zones. As it so happens, the institution running the test was a company rather than a school or university. But as you'll see, the systems can work the same, whatever the institution, whether it's corporate or educational. Let me start by setting the scene. Picture yourself as a British Council manager in Saudi Arabia. Let's take a look. There you are. You've secured a contract with a prestigious company. We'll call it the Gulf Transportation Company for data protection reasons. Magnificent vehicles there. This company wishes to employ 50 graduate engineers this year, which gives you an idea of its size. And it's received over 2,000 applications, which gives you an idea of its high profile. The important thing for our purposes is that some of these applicants are in Saudi, but others are studying in the UK and right across the US, from East Coast to West Coast. Now, GTC will only accept engineering applicants who are CEFR C2 in English. You, as British Council manager, have proposed APTIS, the British Council test, which you've probably heard of, and GTC has agreed. The overseas applicants will fly back to Saudi Arabia to take the test. Everything is settled by February 2020, and the tests will take place in April. Then disaster strikes. By March 2020, COVID-19 is stretching its tentacles across the world, and countries have started locking down. The original APTIS plan will no longer work. But equally, the testing needs to go forward. So what are you to do? Well, what the team needed was a 100% online test with CEFR output. Obviously, it has to be accurate and reliable, and it needs straightforward and simple administration. They settled on the dynamic placement test published by us at Clarity. The challenge was this. With Clarity based in Hong Kong in the east, the company, GTC, and the British Council admin in Riyadh in the middle, and test takers ranging as far as California in the west and the UK in the north, could they run a successful test in a limited time frame across these 17 time zones? It's quite a network there. You can see that it mirrors the kind of arrangement that a university in the UK, Canada, or Australia might have with overseas agents and perhaps exam centres in overseas universities. So, how did it all work out? Let's look at three aspects. We'll start with test security, then move on to problem solving and support. And finally, we'll look at the data coming out of the test. Okay, test security. As you'll be aware, institutions often take a very black and white approach to test security, secure or insecure. They often won't accept the validity of a test result unless it's been properly invigilated. So this was potentially an interesting challenge. Things have moved so fast over the last couple of years that we are now all familiar with the term online proctoring. But few of us have heard of it back then, and it wasn't seen as an option. So we were faced with two questions. Firstly, what options did we have for security? A more practical question. And secondly, how do we categorize the test in terms of high stakes and low stakes? More theoretical. Excuse me. Let's look at the practical side first. Basically, the options were limited to non-existent. Given the setup I've described, there was no way we could set up the kind of system you can see on the screen, where a student logs into a Zoom session and can be monitored or invigilated by an administrator or a teacher. So that was out of the question, and this takes us on to question two. How do we categorize the test? How important actually was it to monitor these job applicants while they were taking the dynamic placement test? In simple terms, let's ask whether this is a high stakes test. And the interesting answer is yes and no. For the test takers, of course, it was. In this case, if a test taker failed to achieve a C2, then that was the end of it. It was game over. They would have lost the job. But for the employer, this was not a high stakes test. If in the GTC case, not getting a C2 would filter the, in the GTC case, not getting a C2 would filter the applicant out, but getting a C2 would not qualify the applicant for the job. It would simply keep them in the pipeline. And if they had in fact cheated, they would be caught out at a later stage, perhaps in the face-to-face interview. So there was no risk that if a candidate cheated, there would be serious consequences. And it was not, therefore, a high-stakes test from the client's point of view. The point is that test security should, in fact, be calibrated to the function of the test. And this may appear obvious, but it seems to be quite a difficult concept to grasp for a lot of people. Anyway, GTC accepted that this is not a black and white picture, perhaps more like this, with many shades of grey, if I can put it like that. And as a result, they were quite happy from both a practical and theoretical standpoint to let the test takers self-regulate. So that was challenge number one taken care of, test security. What about running and supporting the test itself? Well, the admin is pretty simple. You set up all the test details on a screen like this. Then you import the test takers' email addresses from an Excel file or similar and put them into a group. Finally, you marry up the group of test takers with the test you've created. The system will then email them all the details, the URL, the test time, and a confirmation of their username and password. Simple. So the test was duly set up to run between the 9th and 11th of April, and the candidates were informed. But late on the evening of April the 11th, which was the final day of the test, there was a panicked phone call from GTC. They'd had calls and emails saying the test had closed earlier than they thought, and some of the applicants were unable to get in. They'd gone back to their invitation emails and realized they hadn't taken account of the time differences across the time zones. Was there anything that we could do to save the day? Well, yes. Changing the end date of the test is a simple matter. And so we were immediately able to extend it to a new date, matching that in the GTC email. And this shows the importance of flexibility and responsiveness. For robust operations, you need a test that's dynamic. Now, there are other elements to support, of course. For example, you will always get a percentage of the students who can't sign in. This is invariably because they've got their username or password wrong, but you do need to have some kind of support group, perhaps on WhatsApp or Line or another messaging app, to deal with this. So that's just a couple of aspects of security and support I've touched on there. Let's move on now to test output and what we can do with it. First of all, and most importantly, GTC got exactly what they wanted. In terms of operations, the test was successful, as we can see here on the next slide. 2,007 candidates took the test. 1,980 completed it successfully. 23 signed in and then gave up for whatever reason. 3 took the test but did not complete enough answers to get a grade, and there was 1 error. So that was a technical success rate of 99.95%. Right, we can see from the next chart that they were able to whittle down about 2,000 applicants to the 385 who achieved a C2. So removing 1,600 odd applicants from the process represents a massive saving in cost, particularly if you remember as they're originally going to fly them all in to take the test. So for GTC, that's the end of the story, and they walked away very satisfied. So let's finish by considering what we can do with these charts and with the data more generally. And there is data here to make the most jaded testing specialist salivate. Let's look at 3 data sets. Firstly, I'm sure you've noticed something slightly odd about the graph we're looking at. If we compare this with a normal distribution curve, the number of C2s seems too high. Why might this be? Well, I would postulate that there is a correlation between the CEFR level and the geographical location of the test taker. I'd suggest that the seemingly abnormally high level of C2s, because you'd expect the number of C2s to be lower than the number of C1s, I'd suggest that the high level of C2s is explained by the cohort who studied in the US or the UK, perhaps in secondary school. How can we test this? Well, we know the IP addresses of every test taker, so we can run queries to see if there are in fact correlations between CEFR level and the country where the test was taken. Then, if we wanted to, we could take it further. Perhaps we could see whether the same correlations exist between urban and rural areas in Saudi Arabia itself. And perhaps GTC would find this information useful in their next round of recruitment. Okay, here's another interesting chart. For 99.8% of the test takers, we know which device they used. Here it's broken down quite crudely into Mac, Windows and phone, but we can get very much more granular if we want to. We have in fact researched other data sets to see whether there is a difference in performance depending on device, and we found that overall there isn't. But within that overall conclusion, there are some interesting tidbits. We find counterintuitively that test takers complete reading items marginally quicker on mobile. Given that they're working on a much smaller screen and having to swipe between text and questions, why would that be? And again, we could postulate, perhaps this time, that that generation is more comfortable on mobile devices. But there's research there to be done. And there's lots more work that could be done on this. We have other comparable data sets too from around the world. It would be interesting to compare outputs from test populations with different L1s, Chinese, Arabic, Indonesian, Spanish, and others. So if there's anybody out there who would like to do some research, please do get in touch. We have the data. Right, so what are the main conclusions from this test? So firstly, we found that it is possible to test the English level of pretty much any number of learners, large or small, in different places, quickly, efficiently, and painlessly. The most interesting thing for me, the second conclusion, is from a conceptual point of view, we were able to effectively calibrate security to the function of the test. And we were able to define this test as both high stakes and low stakes. Thirdly, the fact that we did have operations issues that were speedily resolved showed the importance of choosing a robust, flexible, and dynamic test. And finally, we've harvested a wealth of exciting data that can inform future testing decisions. And that, equally importantly, is just plain fascinating for future research. Thank you very much for listening. If you'd like to discuss any of the aspects I've touched on in more detail, do get in touch. My email is on the screen, and also the URL for the dynamic placement test itself. Thank you.